Time to work out question 4 of two objects colliding together, and we have to do a mathematical substitution to figure this one out. So let's just get it going because I'm hungry and it's almost lunchtime. First thing before we get started is that there is a mistake in the answers that is listed on the page. V1 prime says 4.6. When you work it out, it actually comes out to be 4.06. And so it's just a typo when writing it down. So V1 prime to two decimal place or to two digits is 4.1 meters per second. And that changes V2 prime, as you'll see when I work out the problem. It's not going to be 3. It is now supposed to work out to be 2.6 meters per second. A little typo when we did the problem first time a couple years ago. All right. Two objects. Object 1 coming to the right or in the positive direction, 2 meters per second. Second object, 4 meters per second, but going to the left. I'm going to set up my x and y direction, do my x direction first. So here's everything that's happening in the x direction. This is exciting. I can hardly contain myself. Okay, before the collision. This setup is the most important part for getting the answer correct. Be very careful in this. If you're going to take some time and slow down during a test, this is it. Before the collision, two objects are traveling towards each other along the x-axis. So x-axis, y-axis for reference, just like in math class. Object 1 in the x direction is traveling 2 meters per second. Object 2 in the x direction is negative 4 meters per second. It is traveling to the left. It is in the opposite direction. So one of those has to be negative. We're given the masses. M1 is 2 kilograms. M2 is 5 kilograms. So that's everything before. That's usually the easy part. After is where it gets a little bit tricky. And by a little bit, I mean a lot. Masses are not going to change. They're not coming apart from each other. And they're not breaking. V1x after the collision. We do not have a number. We don't know. Okay? That's what we're trying to figure out. We're trying to figure out how fast is this object traveling after the collision. So the x component of that, we don't know what that is. But we do know that it's going to be negative because it's traveling to the left of whatever the magnitude is, just V1 prime, cosine the angle. And this angle is 67. So just working out what cosine 67 is going to be negative 0.391 V1 prime. That'll be important coming up. Since we do not know what V is, or V1x, or anything to do with it, all we know is the angle. We're writing this as magnitude times the cosine of the angle. V2x, after the collision, same kind of thing. V2x prime, it's also negative. V2 prime, cosine 35. Just to work that out, negative 0.819 V2 prime. So we won't be able to do any math with our components because we don't know what they are. We don't know what one of them is, but we have our angles. Masses stay the same, so I'm not going to write the masses down again. Let's go to our conservation of momentum in the x direction. I'll write out the formula, m1 v1x plus m2 v2x. That's before the collision, has to equal all the momentum afterwards. m1 v1x prime plus m2 v2x prime. m2 v2x prime. That's how we start every problem. Substitute in what we know. We're not going to know numbers for v1x prime or v2x prime, but we have expressions for them, mathematical expressions. We're going to put those in. On the right, before we can put our numbers in, we have a mass of 2. Initial velocity there before the collision is 2. M2 is 5. V2 is negative 4. Careful that negative. Writing in what we know over here. We have 2 for mass. V1 prime is going to be negative 0.391 V1 prime. So v1 prime x is that. I'm just going to have to move this a little bit that way to get some space. Plus m2 is 5, v2x prime negative 0.819 v2 prime. So it eliminates the component part since we don't know what they are. And we're trying to find for the v2 and the v1 anyway. Simplify this. On the left-hand side, I'm going to have 4 minus 16 equals negative 0.782 v1 prime minus 4.095 v2 prime. Since everything is going to work out to be negative here in a second, I'm going to rewrite it with a positive, so I'll do that in just a minute. So this is negative, whoops, I got ahead of myself. It's not 4 minus 16, it's 4 minus 20 to give me negative 16. Negative 0.782 v1 prime minus 4.095 v2 prime. Everything's negative. I'm going to multiply the entire equation by negative 1. Working with positives just usually leads to less mistakes. 16 equals positive 0.782 v1 prime plus 4.095 v2 prime. That is as far as we can go with the x. Okay, we have one equation, two unknowns. I cannot solve for anything. I'm going to set up my y direction. Before v1y, before the collision, 0. It is not moving up or down. Okay, the way we've set up our coordinate system, it is not moving. v2y, before the collision, 0. Masses are the same. Save a little bit of time and not write them down. After the collision, here's where we have to write it out just like we did for the x. v1y prime equals negative v1 prime sine 67. Negative because it is going down. Take a look at the direction. v1 is, the object 1 is going down, object 2 is going up. Simplifying the sine 67 is negative 0.921 v1 prime. Same thing for v2y prime equals, in this case, positive v2 prime because it's going up, sine 35. So it's positive 0.574 v2 prime. Write out my conservation of momentum equation. I'll write it all out again. m1 v1y plus m2 v2y. Total momentum before equals total momentum after. I almost wrote an x. Slow down, MacDonald. v1y prime plus m2 v2y prime. Put our values in. Now on the left, everything is 0. Okay, both velocities are 0. I'm just going to put that right in there. On the right, mass 1 is 2. Y component going to be negative 0.921 v1 prime. Just substituting the values that we have from up above for v1 prime x. Plus, this one's 5, 0.574 v2 prime. And one more simplification step. 0 equals negative 1.842 v1 prime plus 2.87 v2 prime. All right, that's as far as we can go with this one. I'm going to call that one equation number 2, and I'm going to come up here to my x direction. I'm going to call that equation number 1. Two equations, two unknown variables. We have to solve one equation in terms of the other variable and then substitute it into the other equation we didn't use yet. Math concepts that you did in grade 11 but may have been a while. Just going to write that down. I'm going to solve equation 2. I'm going to solve it for v2 prime just because I know I'll get a positive answer. So down here, I'm going to add 1.842 to both sides. So I have the two values equal each other. Then I'm going to divide both sides by 2.87. isolating the v2 prime. And working that out, I get 0.642 v1 prime equals v2 prime. So I've solved equation 2 in terms of v2 prime. Excuse me, I've solved it for v2 prime in terms of v1 prime. Now I'm going to take that and sub it into equation 1, the equation we didn't use yet. So I'm going to rewrite equation 1 without the substitution. It's 16, not negative, positive, equals 0.782 v1 prime plus 4.905. That's a 5. That's a terrible 5. v2 prime. I've solved for v2 prime, so I'm going to substitute that. So this right here is going in for v2 prime. I'm just going to show that. Won't do any math yet. 4.905 still there. Don't forget about it. v2 prime is replaced with 0.642 v1 prime. Now we have one equation, one unknown variable. We can do this. I believe in you. 16 equals 0.782 v1 prime. Simplifying what's on the right, 3.148 v1 prime. Add your v1s up. 3.93. Then divide both sides by the 3.93. Dividing. We'll get our answer for v1 prime. 4.1 meters per second is v1 prime. That's how fast that ball is moving after the collision. And if you recall from rearranging equation 2 up a few minutes ago, felt like minutes, probably just seconds, 0.642 v1 prime is what v2 prime is. That's just something we did right there. That's what we substituted in equation 1. We're just going to use that again. No need in solving a big equation. So 0.642 times 4.1. 2 prime. Working that out, 2.6. So put it all together. You do a great big therefore. v1 prime equals 4.1 meters per second. v2 prime, 2.6. Put a little square around it. And then let's just, take a step back and look at that. So recap, extraction, break down the components in using the magnitude and the angle. Use your conservation of momentum equation in the extraction, substituting the components in, getting an equation that has 2 variables in it. We can't do anything else. Go to the y direction, same setup, okay, but with your y values, you get a second equation with 2 unknowns, but they're the same 2 unknowns. So the rest of this is our math. Solve the second equation for v1 or v2, doesn't matter which one. Okay, it's a little sketchy. Once you substitute it into your original equation, your starting equation, you can solve for v1 prime. Then we use that in a small shortened equation to solve that for v2 prime. Oh, that was fun. I'll do that again sometime. All right, stop this.